Greetings everyone. Today we're going to explore factoring quadratic trinomials, specifically in this video when a equals 1. So make sure you have the correct notes sheet, make sure you are watching the correct video. Also know, if you aren't in my class, the method we're going to approach this with is the guess and check method. There are other options, but my expectation in my class and with this video is the guess and check method. So, quick review of a previous lesson about greatest common factors. Remember that if you can, you need to always divide out a GCF out of any polynomials we're going to work with. So even if there is another method to use, if it's a trinomial or 4 terms, we need to check for a GCF first. So in this case, I could divide out a 3, which would leave me with an x cubed plus 4x minus 9. So make sure you keep an eye out for the GCF. Let's also review our multiplying rules. Remember that when I have a quantity squared, it means I'm multiplying that quantity by itself. We write it twice. Then I'm able to multiply. Let's say I use distribution. I would have a 9x squared minus 3x minus 3x plus 1. When I combine those like terms, I would arrive at a 9x squared minus 6x plus 1. So today our goal is we're going to start with this type of polynomial, and our goal is to break it up into 2 pieces, 2 binomials. And so essentially we're working backwards today. So let's take a look at some of the patterns here. Again, you don't need to be writing any of this down. We're just sort of talking it out a little bit. I see that my first factors are 9 and my first factors are 3. 3's are how I get to 9. And then I look at my last ones and I have 1's. And the factors of 1 are 1 and 1. Okay, do you see that pattern there? Now, are there other factors of 9? There are, right? Like maybe someone was like, oh, maybe it's 9 and 1. But our goal is to have a little bit of a pattern or to create a 6 somehow, right? And a 9 and 1's is never going to make a 6 in any way. So we got to do a little bit of guessing and checking, thinking about our factors and seeing what numbers create the combination that I need. Again, here's just sort of visual representation. We have been taking care of the multiplying, right? Distributing, adding like terms, getting that quadratic trinomial. But today, we're undoing that. On our foldable, you want to make sure specifically we're looking at part of the trinomial factoring. And if you jump up to the top half of our foldable, today we're only, again, using when a equals 1. If you need the other video, please seek that out. So on the left side, let's write out some steps to factoring when a equals 1. First of all, as always, you need to make sure that your polynomial is written in standard form. Next, if needed, you need to factor out a GCF. Not only for mathematical reasons of simplifying completely, but also because it's going to make the number smaller, which makes it easier for you. Next, we're going to identify our A, B, and C value. We're going to identify the factors of C, meaning the constant. We're going to say, hey, what numbers could multiply to get to C? From those factors, we're going to find a pair that add or subtracts to get the B term, right? We want those factors to somehow combine to get B. We're going to write our factors nice and neat in 2 parentheses, because we want it to look like a binomial times a binomial. Now that we have those steps, we're going to follow through with those steps in our examples. We have 5 examples we are working on today. Let's start with example 1. Step 1, standard form. Check. Step 2, GCF. There's nothing I can divide out. Step 3, we want to find the factors of 6, which would be 1 and 6 and 2 and 3. Remember those factor trees from elementary school? Next, we want to choose the set of factors that will get me to the b value. Oops, I forgot to identify, didn't I? My a value is 1, my b value is positive 7, and my c value is positive 6. If you have it written in standard form, you'll clearly see your ABC. So, factors of C. Which set of factors will get me to a b value of 7? Well, 2 and 3 can't get me to 7, but 6 and 1 can. So here's what I like to do. I like to set up my parentheses. What 2 factors will multiply to get 1x squared? An x and an x. And that's going to be our pattern today. What 2 factors can get me to 6 that we picked? 1 and 6. Now I need a symbol in between. And what's nice is if everything's a plus sign, then everything's a plus sign. That's given. Now you could also have these flip-flopped. You could say x plus 6, parentheses x plus 1. Right? Multiplication's commutative, and if they're flipped around, still good to go. Now, on a piece of paper assignment, on notes, I would like to see those factors written out. I want to see some sketched out work to see what you did, okay? Because there's not much to show, so you got to show me something. All right, step 2, standard form. Example 2, standard form. Good. GCF, nothing I can divide out that's common. Next, let's identify our ABC. I have an a value of 1, a b value of negative 6, and a c value of negative 16. Let's list the factors of 16, 1 and 16. Here's what I do. I count on my hand literally. 1 fits 16 times. 2 fits 8 times. 3 doesn't fit. 4 fits 4 times. And then if I keep going, I'm repeating myself, right? So I have the factors of 16, and today only, our goal is to say which set of those factors can get me to a b value of negative 6. Now first let's worry about the 6. Can a 1 and 16 combine to get a 6? No. Can a 2 and 8 make a 6? Yes. Can a 4 and a 4 make a 6? No. So we can start to set up our binomials. What front factors, if you're thinking FOIL, what front factors get me to x squared? X and x. What last factors are going to get me to 16 that we picked? The 2 and the 8. But here's where we have to play what I like to call the sign game. If 2 numbers multiply to be negative 16, that means my combo of signs, 1 needs to be positive, 1 needs to be negative. Or negative positive, right? The order doesn't matter. But the order does matter in the sense that I want them to combine to make a negative 6. Well, you know what? A negative 8 and a positive 2 added together get me the negative 6 that I need. Here's how I double check. Multiply it out. Right? Here's what's awesome about factoring, you guys. It's a little bit tough. You got to think through it a little bit. But if I distribute this out, I could walk away from every assessment knowing that I'm correct. Because if I do what I already know what to do, I just proved that I'm right. So don't walk away saying, I think I got it. No, prove that you've got it. All right, let's look at example 3. Again, it's in standard form already. I've got an A value of 1 today, positive 5 for B, and negative 24 for C. So 24 is 1 and 24, 2 and 12, 3 and 8, 4 and 6, 5 doesn't fit, and 6 I'm repeating myself. So today my goal is which sets of those factors can get me to a 5? Well, 1 and 24, no. 2 and 12, no. 3 and 8, that could work. 4 and 6, nope. Let's set it up. Today we're looking for two binomials. Today, the front factors that get me to an x squared are a 1x and a 1x. X times x is x squared, right? I'm going to choose my factors of 3 and 8. That was the only pair that could get me to a 5. But now I need to play the sign game again. If my two numbers have to multiply to be negative, I need one positive, one negative. Well, if they have to add to be positive, I need a positive 8 combined with a negative 3. Now again, I could do a little bit of scratch work to prove that I'm right. If I multiply that out, I would have the following. And if I combined like terms, I would prove that I am correct. Let's take a look at example 4 and example 5. The rest of the examples are in our next video. Now this one I'm going to stick to all the same colors. This is what I would expect to see on homework. Standard form, yep. ABC, yep. Factors of 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. Which of those factors can get me to 11? 1 and 24? Nope. 2 and 12? No. Close, but no. 3 and 8? Yes. 4 and 6? Close, but no. Let's set up our two parentheses. The factors out front that are going to get me to an x squared out front are x and x. The factors I chose for 24 were 3 and 8. Now if they multiply to be positive, that means they're either both positive or they're both negative, right? Which set can get me to a negative 11? A negative, negative, right? Negative 3 plus negative 8 is negative 11. Negative 3 times negative 8 is positive 24. See how if I add them or multiply them, I get numbers in my problem. All right, let's look at this last one. Step 1, standard form. Perfect. Step 2, GCF. I have a GCF. I need to divide out a 2. If I divide out a 2, I have this polynomial remaining. Let's treat that inner polynomial as we would the rest of the problem. I'm actually going to set it up, and don't forget that GCF is part of your answer. If you don't write it in your answer, you're not going to get full credit on an assessment because that GCF is part of the question, right? It still exists. Let's talk about the factors of 24. Wait a second, we've been doing this over and over again. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Which of those factors can get me to 11? Wait, didn't we already do 11? We already said 3 and 8. So r times r is r squared. We could have any variable, right? So make sure you're matching it up, correct? A 3 and an 8. Now, if everything's positive, everything's positive. So this is my factored polynomial in simplest form. All right, now that's our video for today. We're only doing guess and check when a equals 1. If you need another video, please check out my YouTube playlist. Check out Google Classroom to see what your task is today. Let me know if you have questions. Seek out help in the Sabre Center. And until next time, have a good one.